This is the Building Automation Monthly Podcast with Phil Zito, episode 76. Hey folks, Phil Zito here, and welcome to episode 76 of the Building Automation Monthly Podcast. In this episode, I will be discussing the question posed to me by a listener a couple weeks ago around just networks and things network-like in general. And I know that's kind of vague here, but it'll all make sense as we get a little bit deeper into the podcast episode. So, as always, everything I mentioned can be found at buildingautomationmonthly.com/76. Once again, that is buildingautomationmonthly.com/76. And today's tip for this episode is going to be all about performing regular scheduled maintenance. And you may be wondering, why is Phil chuckling? Well, Phil's chuckling because I got woken up at 2 o'clock in the morning by my combination smoke carbon monoxide detector that was beeping. So for those of you who don't know, well, pretty much no one knows because I haven't shared this yet, but I am on a new way of eating. I have let my health get out of control. Been too focused on work and Building Automation Monthly. So I have started a no sugar, no grain for 90 days. And that came from the ideas of a couple different podcasters that I listened to that went through it and they saw some really good results. Well, you mix that up with the lack of sleep that I got last night, and things are going to be pretty interesting. But back to the tip at hand. So the importance of regularly scheduled maintenance. And this is one that gets a little weird when you talk about building automation systems, because when you really think about it, really think about it for a second. If I said you're supposed to do maintenance tasks on building automation systems, what would you do? What would you go maintain? Now, don't go and tell me, well, I would go and do, check my HVAC equipment, because that's not building automation. I'm talking if you're going to do maintenance on building automation system, what would you maintain? And, a couple things should come to mind, right? First off, you want to maintain your inputs and your outputs, because ultimately your inputs go into your controllers, which then control your outputs. Once you've got those things scheduled, and what does that look like? That looks like checking to make sure your temperatures are still calibrated, making sure your relays and your dampers and your actuators and all those control devices are working. Then you move up the chain and you move to your controller, where you're going to check your programs, your set points, your PI loops, things like that. From there, you move to your communication bus. Make sure you're not getting a lot of errors on your communication bus. And then move to your supervisory devices, where you'll look at your supervisory devices, and this is where you're going to want to make sure your schedules are good, make sure that your graphics still represent what's going on, make sure that you've done a database, make sure that you're not at capacity for memory or points or whatever structure you have for your building automation system. Then from there, you move to your server, do some backups, patching, make sure you back up your database software, make sure everything's looking pretty good, check your logs, and you're good to go. But see, I didn't do that with my smoke carbon monoxide combination alarm. No, I forgot when last time I changed the batteries on that. So I got woke up at 2 o'clock in the morning to a wonderful chirping noise, and then the way my carbon monoxide smoke detectors are, they're wired in series. So if I unplug one to go and replace the battery, it sets all the other ones off. So that was awesome at 2 o'clock in the morning, going and waking up the entire house. So everyone in the Zito house is freaking exhausted today. But that's okay, because I have had ridiculous amounts of caffeine, and I'm going to get through this podcast episode absolutely just fine. All right, so as I mentioned in my really vague, really weird explanation of what we're going to actually cover today, we're going to bounce all over the place, but we're going to have our lane bumpers on. For those of you who don't know what I'm referring to those inflatable bumpers you put in the gutters in bowling so that your ball does not go out of the lane. That is the only way I can actually knock a pin down in bowling because I'm absolutely freaking terrible at that game. So we're going to stay within those bumpers, but we're going to be covering the topic of networks, specifically building automation networks, protocols, and things like that. Because, I get these questions quite a bit. What is the difference between BACnet Mstp, BACnet Ethernet, BACnet IP? And as you may recall in past episodes, I've talked about OSI model. I've talked about different communication layers, right? So I want to go through that real quickly, do like a brief recap on that, because I think that by providing that brief recap, it's really going to frame everything else that we talk about in this episode. It's going to kind of help it make sense. So here we go. So what the OSI model is basically, it's one of my favorite things to refer to because, I don't know, until I started to really grasp the OSI model, all the things that were going on in application to application communication, it was just confusing. But once I grasped that OSI model, once I figured that out, then everything just kind of fell in place. It all kind of just clicked. So here's the OSI model, essentially, and we're only going to cover the first 4 layers. So what you have is the physical layer, right? This defines the signals that are actually going to come across a wire. Because whenever you're communicating, whether it's MSTP, whether it's wireless, whether it's Ethernet, whether it's fiber, it's all based on digital communication. That means ones and zeros. That means that something's turned on and something's turned off. So essentially and I learned this when I was getting my master's degree in information systems, and I'm not going to bore you with this, but there are a bunch of different signaling standards, right? You've got what are positive signaling standards, which, 0 means off, 1 means on. You've got reverse signaling standards, which, you've got 0 means on and 1 means off. But essentially what you need to take from this is that when there's voltage across your wire, and then when there's voltage not across your wire, your computer, your network interface card, is able to interpret that as a signal. It's called a bit, right? The bit's on or the bit's off. And essentially what happens is, as these bits come across this wire, your computer is able to interpret them, and based on the protocol that is being communicated, the protocol then tells the computer how to interpret all this data. So basically what is happening at the physical layer is your physical devices, your network interface card, your wireless LAN card, are all communicating, and they are creating the signals that come across the wire. Now we move up to what is called layer 2, and this is essentially it's the data link layer. So if you were to think of your home network, right? Your home network, most of you have a home network. And you have a cable or DSL modem coming into the house, and then that goes into a switch, and that switch maybe has a wireless LAN controller so you can access wireless, and it also probably has some hardwired, most likely Ethernet ports that you can connect RS, or not an RS. See, I told you it's going to be a little interesting. An RJ45 Cat5 cable, Cat6 cable into, and then you can hardwire. So you got wireless or hardwire. But the thing is all of that is on what's called a local area network, right? And so here's where a lot of people get hung up. A lot of people get hung up because IP is used on a local area network. However, Ethernet is used on a local area network as well. So people get confused when they hear BACnet over IP and they hear BACnet over Ethernet, and then they hear BACnet over MSTP. They're like, what does all this stuff mean? Well, Ethernet and MSTP, or token ring, are both data link layers, okay? They are essentially the format of the data on a local link, on a local area network, okay? So essentially what happens is, you've got this concept called encapsulation and decapsulation. So as you start to move up the chain from your physical to your application on the OSI model, essentially you are encapsulating all of your higher level messages into your lower level tiers of the OSI model. Now, some of you are like, what the heck did Phil just say? So here's a good way to picture it. It's kind of like when my wife orders ridiculous amounts of shoes from Zappos. She likes to go, and because our kids are growing, she'll order like 7 to 9 pairs of shoes from Zappos, have the kids try them on, figure out which pair works, and then send like 8 pairs back. But basically what is happening is inside that box is a shoe, right? And inside the box is a box filled with shoes. And the shoe is like the high layer message, like the TCP UDP message. Okay? And then that gets wrapped, it gets put into a box, right? It gets put into a box. And that box is like the IP message, right? It's the IP message, it's the IP address. And then that box with the shoe in it is wrapped in a bigger Zappos box that has the Ethernet address, the physical address. So on the outside of that big Zappos box is my physical address to my house. When I open up the box and I have the shoe inside it, it's going to have a number, and that's a logical number. That's the IP address. It's not the physical address, it's the IP address. And then inside is the shoe, which is the application. So basically, as you move up and down the OSI stack, you are taking these messages and you are encapsulating, which means putting them inside another container, and decapsulating, which is taking off what are called essentially headers and footers of the message. So the first part and last part of the message that wraps the message. Okay, so are you with me? Now I'm going to go through this one more time, and if it feels like I'm belaboring the point, it's because this is a hard concept to grasp, but once you grasp this concept, it makes things so much easier. So as I said, you've got headers and footers, right? And headers and footers are these little messages that go around the other messages. So basically, the Ethernet, the Layer 2 data link, or Mstp, those headers wrap the other message. They wrap the IP, they wrap the TCP message, okay? So then the Ethernet wraps it, and then the IP wraps the TCP UDP segments, and they all just kind of wrap up. And that is essentially how networking works. Now, why do I tell you all this? It's not to confuse you and make your head spin and you're like, holy crap, this makes no sense, because I realize this is a complex topic. It's so that you can appreciate when you hear things like BACnet IP and BACnet Ethernet and BACnet Mstp and things like LAN FT10 and Modbus TCP, you're like, what does all that mean? Well, that has to do with the protocols of which these different communication standards are communicating, the layers at which they're communicating. So BACnet Mstp is a local area network, meaning MSTP, master-slave token passing, and it's a daisy chain network from a source controller, typically a supervisory device, and it goes daisy chain, meaning boom, 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 one after the other. You can't see my hands moving on the podcast, unfortunately, but essentially what happens is it's like a little hop from each device to the device until you reach the end of the line. And that is a isolated local area network. Each MSTP network has its own network instance ID. Okay, so then these wrap up to the supervisory devices, and these supervisory devices are taking this MSTP language and they're converting it to BACnet IP. Now, BACnet IP can exist across multiple different links, across multiple different networks. So you may have a supervisory device on one subnet and it has its own BACnet MSTP trunk, and then you have a supervisory device on the other subnet and it has its own BACnet MSTP trunk. But how do they talk to one another? Well, they have to route, right? And I've covered this in previous episodes. I covered in my IT course, which, by the way, is open for enrollment right now for the month of July. And I really encourage you to hop in there if you're trying to learn this IT stuff because, one, it's going to be closing in the month of July and probably not opening for a long time. But two, it is just massively increasing the knowledge of IT for a lot of folks. And there will be links to that in the show notes. So, as I was saying, the supervisory devices are going to route traffic through a router and a route to another subnet, to another network portion. That network portion will have the other supervisory device on, and then it will communicate down to that BACnet Mstp trunk on that supervisory device. Now, this is why you can have MSTP trunks that have the same network identifier on multiple different controllers because they are separate. They are their own little layer 2 instances. And that is why, and then they're up at the supervisory device, they're converted to BACnet IP. So it never gets seen by these other BACnet devices as being a conflict because they're on other network segments. All right, does that make sense? Hopefully it does, because we're about to dive even deeper. So when you hear this whole MSTP, what that is that's a layer 2 construct. Essentially, it is a network that exists in the data link layer and not the IP layer. That traffic without the assistance of BACnet IP is never going to go anywhere. It's never going to leave that supervisory device and go anywhere else. Now, back in the day when you had all these things and you had these BACnet MSTP trunks and you had these supervisory devices, but you really didn't have robust routing. Everything was kind of on its isolated LAN. A lot of these data packets had to get to other supervisory devices. But we didn't want to go and give everything IP addresses because just quite honestly, the products weren't that mature back then. So you had this concept called BACnet over Ethernet, which you don't really see much anymore. But Ethernet is a way for communication to communicate over a local area network using that layer 2 of the OSI model, whereas IP addresses are layer 3 and can go across multiple subnets using routes. Layer 2 Ethernet messages use MAC addresses, and you're like, oh, that's interesting. MSTP field controllers have MAC addresses as well, don't they? Yes, they do. And while Ethernet MAC addresses are 8 hexadecimal numbers, 4 of which are the manufacturer's code and 4 are unique to that network identification card, the media access control MAC address for most field controllers are a set of 8 bits that are on and off, and binary math adds them up from 0 to 255. And so essentially what's going on here is these MSTP devices or Ethernet devices are able to physically communicate across the local area network, but they are never able to quite get out of that local area network. And that is where that whole BACnet IP comes in. So on one instance, you know that IP is routed, and it is routed from one device or one network to another network using a route through a device called a router. But then how does the BACnet IP protocol know how to get to other networks with BACnet devices? Well, this is where you have what is called a BBMD, a BACnet Broadcast Management Device. And a BBMD essentially is kind of like a router, but it's specific for BACnet. And it's going to understand the different BACnet networks, and it's going to understand the subnet addresses to these different networks. Because what happens is BACnet is mainly a broadcast protocol. It is a UDP protocol, meaning that it is connectionless, and more on that later. but it is a broadcast protocol, meaning that it sends out a who is message and then receives an I am message. So it'll send out to all devices on the subnet, who is this device? And then the appropriate device will respond with what's called a unicast message. That's a message to a specific IP address, whereas a broadcast message is a address to all the different IP, or to all the different devices. And it'll send out this broadcast message, and then the specific device will respond with the unicast message. And I'm not going to dive into much more of who is, I am, all that kind of stuff, because quite honestly, it's, for most of you, you're not going to need to know that. You're not going to need to know that kind of depth. You're just going to need to understand that if you have multiple subnets, you need BBMDs, and that certain messages get routed, and why it's important to have unique network identifiers for IP, but why you can get away with having the same network identifier for communication trunks. It's those kind of things that you're going to have to understand for both a sales, from a technical, from a product management. You're going to have to understand those core concepts. All right. So as I said, BBMDs. So these BBMDs do the broadcast management, and then once the broadcasts are managed, then we have layer 4. So we've handled our IP layer, and now we have layer 4. Layer 4 is the TCP UDP layer. So TCP is this transmission control protocol. And one way you can see this actually working, and it's really unique, it's kind of cool. Well, for the nerd in me, it's kind of cool. If you ever go and you start transferring files to another computer, and they're big files on the internet, you'll notice that typically your beginning part of that transfer will be slow, but it'll gradually speed up more and more and more. And what is happening is whenever you're doing file transfer, you're using a connection-oriented transfer. Because what you don't want to happen is, in the world of the internet, messages can take different paths as they get from the source to the destination. And what can happen is these messages can get what are called fragmented, meaning some of them you receive sooner than the other ones. So what happens with TCP, it creates this connection, and it uses these sequence addresses so that you know where that message is supposed to fit in the greater scheme of things. And then what happens is the receiving the destination device, if it doesn't receive the message that it's supposed to, it'll send back a message saying, hey, last message I received was 105, and then the destination computer will restart sending messages. So what's happening behind the scenes when you're sending this is you have these window lengths, right? And basically there's these message lengths. There are these windows between how often you go and do this acknowledge sequence. And those windows go bigger and bigger and bigger so that you're sending more and more data until the point where the destination computer either can't keep up or the network can't keep up, and you start losing messages, and then it'll throttle down. That's why you'll see your send times increase and decrease. And it's kind of weird because you watch it and, sometimes it'll be like 1 hour and then all of a sudden it's 8 minutes. And it's because you had a window length that was expanded. And so now you're sending more data in between those confirmations, which is going to make your data transfer faster. But all of that said, so like TCP, that matters for Modbus, right? Because Modbus is a TCP protocol. It's Modbus TCP or Modbus RTU. And so Modbus TCP is going to be where you're using IP addresses and you're creating connection-oriented messages. And I wonder why they went down that path, because UDP is much more lightweight. I think probably because they're thinking, hey, Modbus TCP is mainly an industrial protocol, and they really want to confirm that the messages are getting through, because you don't want to mess up like a whole batch of stuff on a line. That would be really bad. Whereas UDP, it's kind of fire and forget. And so UDP is called a connectionless protocol. And a connectionless protocol, what that does for you is that's fire and forget. That's like me yelling at my kids, right? I'm like, hey, kids, do this. And then I don't hear anything. Well, there's one or two ways I could do it. If it was a connection way, I would expect them to acknowledge me, and if they didn't acknowledge me, I'd yell back at them again. However, connectionless would be me going, hey kids, go clean your room. And then I never check if they clean their rooms. I never go and actually follow up if they don't respond. That's the big difference. Now, a lot of folks' initial reaction when they hear this is to think connectionless is bad. After all, if you go and send a chiller on command and that chiller on command never responds, well, then that could be really bad, right? Well, that is why you have the BACnet protocol, which is going to go and it's going to provide feedback. It's going to adjust to show that that command actually changed. So when you send a command, it'll then go and adjust the state of that property. That present value will change from off to on. And what's going on here is even though you're sending this fire and forget message, you'll still see visual confirmation that things have changed on your graphics. And that's why it's always important to check that your actual changes are happening. I've seen people who are like, well, I had the central plant scheduled. And I'm like, yeah, but did you check to actually make sure the message got through and the central plant turned on? Well, I had it scheduled. I'm like, yeah, and someone was doing maintenance work on a switch, took down your network, and the message never got through. So those are the kind of things that you need to be cognizant of. You don't really experience that with BACnet Mstp because if the trunk's down, nothing's going to show up as online. However, if you are able to see things and then all of a sudden there's like a blip and the message gets missed for some reason, you're still going to see devices as online, but there's no confirmation that your message actually got through. All right. So with that being said, so we covered MSTP, we covered the physical layer, we covered TCP and UDP. Now I'm going to talk about what are called priorities. So when it comes to BACnet, you have what's called a priority array. And this is really cool because this is like computer sciencey stuff. Basically what's going on is instead of just having every freaking one and their person and their mom sending messages at your building automation system and it just going crazy, with BACnet you have what called priority arrays. And essentially a little kind of segue into classes, data models, and stuff like that. BACnet is an object model, right? So you at the top you have your device object, and then your device object, maybe it's a supervisory device, and it's going to have what are called properties. Okay, so that object is going to have properties like present value, device description, those kind of things, fault, reliability, etc. Then underneath that object, you'll have then a communication bus object, and under that communication bus object, you'll have a field controller object, and under that field controller object, you'll have point objects. So you may have field controller, like application-specific controller, and then you may have a analog input and a analog output. And those are objects, so it's a parent-child relationship, right? So the objects fall under, and they gradually build a hierarchy. So, supervisory device, COM trunk, field controller, points, and under those points you're going to have your properties as well. Under every BACnet object you have properties. Well, one of the properties you can command the present value, you can command the priority array. So if you want to change a value, then what you can do is you can send a write command. That is a BACnet function, and a function is basically just a command. It's a computer operation that performs something, maybe like read status or command or schedule or alarm. Those are all BACnet functions as well as BACnet objects. So as you write property, what happens is you would write to that present value property and you would write to it at a level on the priority array. Now with the BACnet priority array, the higher the number, the less value it has. So like 15 is not near as important as 8. And you've got your common priorities, and I'm not going to go through a whole priority table, but essentially you've got these priorities, and each priority has a different value to it, right? So you have your priority 15, priority 14, priority 8, and 8 is often known as the override. So this is the manual override. This is where you're going in, and I know I'm butchering the name. It's not called manual override. I know exactly what it's called. I'm going to pause it and get it for just a second. Oh, that's funny. I was actually right. I Googled priority array, and I was like, hey, it is manual operator override. I was absolutely right. Yeah, go caffeine. No, but in all seriousness, so that operator override, essentially what that is that's like a maintenance override, right? You want to operate a valve to make sure that it's maintaining or stroking properly, or operate a damper and make sure it's open. Now, I would never, ever, 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 ever recommend that you use code as safety overrides. Like if you're going to go and I'm going to manually override the fan off so I can go work on the fan, no, you should actually go turn the breaker off. Make sure there is no possible way that that fan can turn on. I mean, that's just a little safety moment right there. I think most of us know that, but software is not an override for you to physically go and work on systems. Do not do that. Do not pass go and collect $200. All right. So these priority arrays, what happens is you write at different priority arrays, and they then go and they create different levels of importance. So the lower the number, the more important it is. So that's how all that works, okay? That's how all of that comes together. So what I wanted you to take from this episode, I wanted you to take an appreciation of the different layers of messages. And I know this is a little abstract and a little hard to understand at times. So here's what I'm going to leave you with, okay? So a field controller sits on a BACnet Mstp trunk, and it sends a voltage signal across the positive, negative, and common wires. That is your physical layer. That's your layer 1 of your OSI model. Now, most BACnet controllers right now use Mstp. This is changing. We are moving as an industry to IP and wireless 802.11 controllers. And if you don't know what that stuff is, once again, I'm telling you, check out my course. It's self-paced, online, and you will learn so much about IT. I've heard nothing but good things from my students. But as I was saying, most field controllers right now are BACnet Mstp, and they use tokens. And essentially what happens is the token is basically like an Ethernet frame, right? So an Ethernet frame is a message type. Well, you have a token, and that's a message type for the Mstp message standard. Okay, so you're sending these tokens up and down the wire from field controller to field controller. That's layer 2. Now, all of this gets consolidated in your supervisory device, which on the upbound link speaks IP. You know, you've got an Ethernet cable inside it because remember that LANs, local area networks, they're going to use both Ethernet and IP. They're going to use Ethernet for inter-LAN communication, because that's going to allow them to communicate physically from device to device. However, they're going to wrap their messages in IP, and then they're going to have inside those IP messages TCP and UDP ports, which are going to be specific to applications. All right, so what's happening is layer 3, we're sending our IP messages from our supervisory devices out the subnet to maybe another subnet to another supervisory device, maybe in another building. And we're using our BBMD to tell us where our BACnet subnets are. And then once we get into that subnet, we send out our messages, our broadcast messages, which is an IP feature. Now you may be wondering, once again, why do I need BBMDs? That's because broadcasts cannot traverse network segments. What would happen if a broadcast were to traverse a network segment? You would have all these broadcasts from all these different networks going all over the place, and it would just be utter chaos, and the internet would just collapse. I don't say that lightly. Broadcasts are extremely chatty, and they are the primary way that networks identify who is what. So as I said, you've got your IP traffic going across. On top, or actually underneath that IP traffic, you have your UDP traffic, which is the actual BACnet communication. That's where your NPDUs and your APDUs are going to sit. And that's a whole nother can of worms to talk about network protocol data units and application protocol data units and how all that stuff works and how network stubs work and just all that advanced kind of BACnet craziness that I'd say a good 99% of you really don't need to know. And the reason I tell you that is I don't want you going down the trap I went down. I literally, in my closet, I have all sorts of books: Microsoft Business Intelligence, Advanced C#, Advanced C++, RESTful APIs, Cybersecurity, Black Hat, the Hacking Exposed workbook. I have all these books because, at one point in time throughout my life, I've wanted to know all these different things about IT. And I could never really figure out what I really needed to know for my building automation career. And that's why I tell you, when I say you don't need to know something, it's not me just trying to be a buzz killer and be like, you don't need to know this, I'm not going to tell you. It's because I realize that knowing that, it's not going to impact your career versus the amount of effort it's going to take for you to learn and understand that. So it's just not really valuable for you. All right, with that being said, I really hope that this podcast episode has just really helped open your eyes to how all this communication happens. I know we described the same thing like 4 freaking times here, and you may be like, Phil, you said basically the same thing 4 times. I know I did, but I wanted to give you multiple analogies, multiple different examples, because these are abstract topics. They're hard for the human mind to visualize. And I didn't want you to get so caught up on one of the topics that you really couldn't understand what was going on, because I was guilty of that. I had to hear things multiple different times before it really resonated with me. And I realized that that's how most people are. And so I wanted to give you all these multiple topics, or multiple examples rather, of this single topic. All right, so with that being said, this is most likely the only podcast episode I'm going to record this week. This week is kind of my off week because it's just kind of time for me to chill and settle down. And then we'll be back at our regular frequency of 3 episodes a week. But don't quote me. I might make another episode or 2. It just depends how squirrely I get this week. If I start to get antsy and, I start to get a lot of questions. Which, by the way, go to buildingautomationmonthly.com/question or questions, and I will put your questions in the queue to get answered on the podcast. And like I said, everything can be found at buildingautomationmonthly.com/76. Once again, that is buildingautomationmonthly.com/76. That's where you'll be able to listen to the podcast. You'll be able to subscribe to iTunes or Stitcher, leave reviews, leave comments, ask me questions. And yes, you will also be able to click on the link to register for the July class of my information technology for building automation system professionals, which I really encourage you do. It is the best class you will find. I'm not just saying that because it's my class. You really won't find anything else out there that teaches this much stuff that you need to know, that's created by a building automation professional, that's online, so you don't have to travel, that is at the cost I've made it at. You won't find anything else out there like that. All right, and with that being said, depending on when you're listening to this, have a good 4th of July, or hopefully you had a good 4th of July. And I will talk to you in the next episode. Take care.